In this demo, we're going to turn some scrap copper metal into copper oxide using a couple of processes. The first process we're going to use is electrolysis using a solution of sodium chloride or common table salt. Our electrodes are from some copper water pipe. We've split the cathode down the length and opened it up, and the anode we've cut a notch in the side to help rest on the side of the container. With our copper electrodes partly submerged, the next step is to hook up our DC power supply. We're going to connect the negative terminal to our copper cathode. This happens to be the tube that we've opened up. And the positive terminal we're going to connect to our other copper tube, which is going to act as our anode. Now we're going to turn our DC power supply on. We have a multimeter to measure current. And with our power supply turned on, we've got roughly around 8.5 amps going through. And immediately our copper cathode, we can see a lot of gas being produced. This is of course hydrogen. And our copper anode, we're not getting much gas produced at all. A number of chemical reactions might be taking place in this electrolysis setup. Firstly, electrolysis of sodium chloride solution tends to produce chlorine gas at the anode and hydrogen gas at the cathode. Sodium hydroxide is also produced, however this remains in solution. As we are using copper as our electrodes for both our cathode and anode, this may react with the gases being produced. Copper metal tends not to react with hydrogen, however copper can react with chlorine to form copper chloride. Any copper chloride formed may in turn react with sodium hydroxide which is being formed to form copper hydroxide and reform sodium chloride salt. Another possibility is that the copper anode may also react with oxygen to form copper 1 oxide or copper 2 oxide, the difference being the oxidation state of the copper being 1+ or 2+. Given the number of chemical reactions that could be taking place in this electrolysis setup, it is likely that we're going to produce a number of compounds. This may include copper chloride, copper oxide in the form of copper 1 oxide or possibly copper 2 oxide, and the formation of copper hydroxide. And what we can see here is a reaction product forming in our copper anode and indeed consuming it and falling off towards the bottom of the container. We let our electrolysis cell run for 4 to 5 hours before switching it off and allowing the products to settle. On removing our copper anode, you can see quite clearly that some of it's been consumed in the process. On removing the copper cathode, with the exception of some of the reactive products from the copper anode deposited on the surface, it doesn't appear to have reacted in this setup. Next, using a coffee filter paper, the solution is filtered. Taking care not to disturb the settled sediment, the liquid electrolyte is easily filtered off. Then, using a stainless steel spoon or spatula, it's quite easy to scoop out the product from the bottom of the container into the filter. Since copper oxide is not very water soluble, it is possible to wash away any dissolvable salts using demineralized water. When most of the water is drained through, we can then carefully remove our filter paper and allow it to dry. Okay, so it's been drying for a couple of days now, but it's still a little bit damp. So to speed up the drying, we're going to break it apart into a finer powder with an increased surface area. So with our finer powder, we've allowed it to dry for a few more days, and it's now very dry. However, it's quite clumped together, as you can see. To turn this clump powder into a finer powder, one option is to use a homemade shatter box. So to do this, we can use a plastic bottle, which we add our clump powder in. help break it into a finer powder, we can add some nuts. Just carefully screw the top on, and then we shake it. Now the nuts will impact the coarser powder, breaking into a finer powder. To fully oxidize our copper to copper 2+, its highest oxidation state, we're going to roast in air. We're going to sieve our powder to remove any large agglomerates and provide us a fine powder ideal for roasting. We then add our sieved powder to some clean, heat-resistant ceramic dishes. We then roast our powder using a gas torch, and over time we'll see our powder go black in colour as it's absorbing oxygen and converting the highest oxidation state of copper 2+. If we stir our powder with a stainless steel spoon or spatula, this will help the powder come in contact with air or oxygen. After about 3 to 4 minutes of heating, we switched our gas torch off, allowed our powder to cool down back to room temperature, and let's see what we've got. If we empty our dish, we can see the powder is black in colour, and this is what you would expect for copper 2 oxide. Thanks for watching.